All right, I think we're at the top of the hour, or just after. So thanks everyone for joining. My name is Kyle Miller. I'm not sure if you guys can see my video. I might need to have Ravi and the rest of the gang help me because I did just do videos off. But either way, thank you all for joining. We're really excited to be able to host a webinar, DJI, Strayos, and Wesco all together to be able to talk and discuss more about mining. Ultimately, we're going to be talking about some of the use cases, some of the workflows that Wesco has been able to develop with their drone program, how they've utilized DJI drones specifically, as well as how they've been able to leverage AI with a software company called Strayos to kind of up level the game beyond stockpile measurements. So with that being said, let's go ahead and kick it off. If the rest of the gang wants to do videos on as well, and maybe, okay, good, we can see video, perfect. David, Curtis, Ravi, are you guys all video on? I apologize that I'm not able to see webcams right now.
We are.
Perfect. All right, so just a brief round of introductions. My name is Kyle Miller. I'm a solutions engineer at DJI. Been here for about a year and a half. And my background is geospatial, and one of the large sectors of the geospatial industry is mining. And so with that, I'm really excited to bring on David. I'm really excited to bring on Curtis as well as Ravi. So David, you want to go ahead and do an introduction?
Yeah, thanks, Kyle. My name is David Moulton. I work for Wesco, a Western Explosive Systems company based out of Salt Lake City. I've been doing drilling and blasting for just over 16 years, and excited to talk about drones and AI and kind of the different things that we're doing.
Glad to have you on. Curtis?
Yeah, good morning. Curtis Thompson. I'm a mining engineer, drone blast engineer for Wesco. Been doing mining engineering for over 15 years, been in the industry for about 17 years. Look forward to discussing all the new technology and build understanding of the mining world so that we can all move forward and help each other out.
Perfect. And Ravi?
Thank you, Kyle. Hey, good morning, good evening, or good afternoon, everybody, wherever you're dialing in from. Great to be here and appreciate DJI putting this together. So my name is Ravi Sahu. I'm the founder and CEO of Strayos. Strayos is a computer vision and AI software company that combines remote sensing and 3D data to build mining AI solutions. My background is in the software side. Before starting with Strayos, I worked globally in Asia, UK, Canada, and a bunch of different places to build enterprise data application. Happy to be here.
Perfect. All right, so a couple of housekeeping things before we move on. First off, this webinar is being recorded, so at any point you're going to be able to go back and watch this. Generally, we post this on our DJI YouTube channel within the same week of the webinar. We also have an area for questions, so feel free to drop any questions that you have, and we should have about 5 or 10 minutes at the end to be able to go through those, and also we can follow up after the event. We are also going to have 2 different polls here, and we'll get one of them going in just a moment. So glad to have you all here. All right. So we see a number of different challenges within the mining industry. There's quite a bit on this slide, but I'm going to open this up to Curtis and David. What are some of the biggest challenges that you guys see at Wesco on your day-to-day operations, and how have drones kind of started benefiting that? Or I guess let's start with, what are your main problems and challenges and pain points from your day-to-day?
Yeah, I think some of the things I think about, obviously safety is a big part of it. Asset management, making sure that you're getting the most out of the assets that you have. And then always the costs associated with that equipment, either managing downtime or efficiency with equipment. those are some of the things I think of. Curtis, I don't know if you have some additional thoughts there.
Dave, I think that's great. I think all of it, first and foremost, safety, being able to not put people in tough situations. Second, production comes to mind as far as, limiting downtime. Ultimately it's about getting the ore out of the ground safe, cheap as possible. And I think, those are probably the main things that we struggle with large and small customers.
Sure. So you talked about cost. How has surveying in general within mining, how has that cost and technology adopted over the past 10 years? Or what does 2013 or 2011 look like for surveying within a mine?
Yeah, I think for us, specifically as a drill and blast contractor, what we found is that, we were only using survey equipment when it was absolutely required by the job. And then, at some of the smaller mining operations, they may have a person that did some of the surveying, but it was limited, kind of as needed, and not as widespread adoption. Bigger mines, definitely see it more common, but definitely seen a big change just with the introduction of drones.
Yeah,
Sure.
as Dave represented with just the drill and blast side, I mean, you're talking about guys out there, with tape measures, marking with paint. I mean, that was pretty much our surveying for the most part. Then it kind of moved into face profilers, which we were able to use lasers and total stations to profile the face, but overall the change that drones and AI and computer software is bringing to the table is going to change the industry, not only for drill and blast, but already has for mining over the past few years.
That's great to hear. So frequency is a big one, as well as sounds like maybe accuracy too might be a big one, where drones are potentially able to help out. Total stations though, yes, we've all been around those for many hours. Cool. So at this time, I am going to kick it over and start a poll. And it actually, let's go ahead and launch that. So the poll is open now. It kind of relays back to what Curtis was saying. How frequently are we able to get on that job site? So go ahead. We're seeing some answers trickling in. It seems like the majority is kind of hovering around either the ad hoc or the monthly drone flights, which seems fairly reasonable. Curtis, David, what are you guys seeing as far as frequency? Or what would you click here?
I would, this is David, I'd actually click daily, doing daily.
Yeah.
It's been a big progression for us as Wesco diving into drones and the utilization of drones. I would say we were pretty ad hoc at first, and like David said, with a lot of our customers, we are a daily flight now.
Yeah, cool. That's great to hear. And it ends up being, you start using it for one use case and you find more and more and more use cases, and then it ends up being out of the box Monday through Friday and sometimes Saturday and another time Sunday. So cool. At this time, we're going to go ahead and kick it a little bit over to Ravi to introduce Strayos. Going to run through some slides just about the platform, but then we're going to be finishing up. The bulk of the presentation is going to be how Wesco specifically uses Strayos and some of their overall day-to-day operations. So I'll kick it over to you, Ravi.
Thank you, Kyle. So I just wanted to walk through, what Strayos is and what are the tools around Strayos that we have developed here. So a bit of an overview about the company. The solution is used in roughly 25 countries in around 3,000 mines and quarries apply this on a daily basis. And we have a global presence in terms of how we support our customers. And a lot of data has been gone through since this is used on an operational basis. We process more than 75 million imagery data point, and there's a lot of operational cost savings that has come up through that. Next slide, please. So what's the platform is? So Strayos has injected an AI solutions at each step of the mining value chain. And drones and the geospatial data is really the crux of that. So starting from 3D photogrammetry and survey data, bringing in your imagery, LiDAR data to process it, and then taking it a step further, which means on the same data layer, there's an AI which can extract the geological information, such as rock mass, and then it can be further applied to full suite of drilling and blasting pattern design and optimization. And after that, the drilling data can be brought back in the same 3D geospatial layer to see what's the hardness, softness of the rocks is from the drill data. Moving a step further after the blast happens, you can analyze how the blast outcomes is, and then understanding of what's the loading and hauling condition would be. And then further reporting of the different environmental conditions that exist in the site. So overall, really the drones are enabling all this value chain here now. As I see, we started with more as a survey use case or survey data, but taking it, this is becoming an integral part, the drone data or any sensor infusion that comes in to enable all these use cases. And that's where we are seeing that the previous survey question, moving from monthly or ad hoc, and how Wesco has transformed to a daily operations because of this enablement of these use cases now. Next slide.
Well, before we move on, Ravi, I want to just make one quick note. The thing that surprised me the most about Strayos is there are a number of different platforms to be able to do one or two of these things, such as the automated stockpile reporting, being able to measure stockpiles, or be able to generate a 3D model and overlay something on top of that. But the actual AI that you see for blast planning, and we'll talk about more of it further, has really, it's kind of blown me away as far as understanding what is possible. And I haven't seen really anyone else do a lot of this type of AI reporting.
Yeah, that's very true, and I think that kind of flows into the next part of this slide here is, so what changes with the Strayos? And the simple answer is nothing changes for the users. You are just getting more value from the drone data you're capturing, all the tools that you have. So you have a photogrammetry which you can process in Strayos or bring the data from the other solutions as well. But then a lot of the value lies on how you use these photogrammetry outputs to turn into something meaningful. And that's where majority of the also time gets spent. So you have CAD-like solutions. So if you click again, Kyle here, you will see like what is the combination that comes in, which means same workflow, but way more value and way more use cases. What it enables is going from this ad hoc or monthly flights to a daily flights. That means your processing power gets much more better and faster, and the use case you can measure more every day, bringing the drone data as kind of your heart of your operations use case, not just we are measuring it for the survey purposes now. So quick answers, quick enablement of the operational decisions, and that's what kind of we are striving towards here. Next slide. So I want to talk some of the use cases that you can go today and start thinking about, right? So I want to cover 4 of this today, and then David and Curtis will go even more deeper how they are doing it. So combining drones and AI, what are the mining use cases that are possible here? So haul road assessment, Highwall, Geotech, and slope safety, design conformance and pit analysis, and a bit more on the drill and blast intelligence here. So we'll look at the next slide as the first use case of haul road. So what it enables is you have your data outputs, which is Geotech or point clouds or a DSM. But now the AI layer can inject and you can easily analyze automatically where the issues are. And one of the quickest ones is the haul road assessment. By combining these different data types, it can analyze where the grade issues are, where the berm height issues are, super elevations, where the water drainage issues are, which is the common problem in the large mines that has a huge impact on overall wear and tear on the tires, how the fuel cost gets impacted. Now you can bring that machine data and layer on top of the drone data to see how to optimize it. So now we can really nail down which are the areas that are impacting the most on our day-to-day operations and where the marginal improvement we can make on the road improvements here. So staying compliance, staying safety is one of the key things, but also how can we reduce the cost of loading and hauling and make our routes much more better on a day-to-day scenario here.
So just to make, just to make sure this road grade, you didn't like draw these lines and then it just gives you the grade. The AI is actually finding all of your haul roads for you and then also putting a score on those grades.
Exactly, yeah. So it is all automated. It is all fully, the reports are also automated. Users just have to kind of, go and look at it, and the alerts and notification can also be built if they want to integrate into their dispatch system.
Cool. All right, next one.
Yeah, the next one, I personally feel this is one of the very underlooked areas, not in terms of how the operational and the geotechnical teams makes a decision, but this is one of the area where drones are very underutilized, and I see a big benefit there. But then the manipulation of data is where the majority of the challenges are. So again, AI is a very useful tool here where you can train a lot of data sets to understand where the slope displacements are and the risk factor is. So AI here is combining the data of the rock mechanics information, rock mass, and predicting the areas of high risk. So not only it's giving the true traditional or more kind of imperial related, empirical related information, but also it is using the past and historical data of how the displacement will occur and combining that to predict the risk factor. And this is entirely a drone data here. There is nothing another sensor fusion here. So I think it's moving from like these expensive and bulky radars. If we can apply drones on a daily basis, it creates a huge value. Similarly, on the geotechnical side, which is automated rock mass characterization, and what that means is essentially identifying different joints, discontinuities, faults, cracks in the rock. The DJI has been producing tremendous cameras these days now, which are able to pick up all this information. And AI, if you apply its automated identification of these positions of bedding and faults and different seams, can lead to huge improvements of how we design our high walls, how we do a better wall control, and how to do a structure analysis on these high walls.
You mentioned about being able to fly this type and doing this type of AI daily so that you can like track change over time or see if there would be any faults very quickly. And we saw a photo of a dock on one of your earlier slides. So just hypothetically, having a dock solution with the Matrice 30T, being able to go out and grab some maps, some models, be able to process that data. We also just shout out to release the SDK for the dock. So you're going to be able to start seeing companies really start building on that SDK so that you're going to be able to get that data piped wherever you need to pipe it to so that you get these types of analysis. So with the new dock SDK and some of these types of analysis, it has me really excited for autonomous mapping of mines daily.
Absolutely. And just continuing on the same topic here, like, how more data and the autonomous dark solutions, I think that's just it's paving the path for, like, so many use cases. Another one is the compliance and the safety side, and that has an operational correlation as well, how we can save the cost. So AI can auto detect the crest and toe, which is essentially a line that follows for each of the high wall. And the measurement of this high walls becomes equally important, not just to kind of understand geometrically, but also how to design a proper blast, or how do we maintain a proper wall control. So identification of this crest and toe is based on AI, and then it determines, where the issues are in different areas of the high wall with angle, height, inter-ramp angle, which is the difference between the different walls, catch bench width, which is the safety distance. If there is a slow failure will occur, whether the rock will catch in different levels of the high wall or not. So all this is a very making the drones are making safer with this frequent analysis. The way I see the tools when combined together with drones and AI here.
Cool.
And the last one here is more on the drill and blast side, which is an activity that happens on a daily basis in most of the mines, sometimes 3 or 4 times in large mines here. One of the key metrics that occurs is the overbreak and underbreak, and these are really a relation of the blast-induced damages that occurs in the high wall. If you are able to monitor that on a regular basis, if you fly every time a blast is occurring and you measure the overbreak, underbreak, you can update your geotechnical model or structure models on a real-time basis. Usually this information gets updated once in a 6 month. By the time, a lot of the issues that continues to happen and cascades at a overall larger operational performance that mine should have seen doesn't get noticed then. So if we can do that, where the issues are in the high wall with overbreak, which is the red hotspot areas where overbreak is, if we can identify very easily on a real-time basis, we are seeing more and more cost improvements there. Then there are other use cases such as identification of floor hotspots, or where the different changes are on the elevations in the floor. So if I bring in the equipment to move that material, I know exactly where the issues are. Identification of the parent deviation, where my drill hole is supposed to be drilled, but it's not drilled. If I can identify very quickly with another drone flight and combining AI to auto detect holes, another use case there. After the blast, when the material is on the ground, if I can identify where the different rock particle sizes are, that helps my crusher improvement. And then finally, which is another level of improvement, if I can bring my drilling information to see with the drone data exact hole position, what's the hardness and softness of the rocks are. So I can know exactly how to model my blasting conditions. Like,
yeah.
So this one really just encompasses, like, what are the benefits that can come in, which means site throughput can improve by 5 to 10%, 10% reduction in overall operational costs of drill and blast, and then the 30% reduction in deviation from overall mine planning to what you are supposed to be doing. So these are some just general ROI discussions here, and we can review that later as Curtis and David will talk more here. So yeah, thank you very much.
Good information, Ravi. I'm going to go ahead and kick off the second poll. I think it's very, I think this part of the webinar, I think that type of poll makes a lot of sense. Are we capturing data and utilizing a lot of these types of AI tools? Or are we mainly just going out and capturing them and then utilizing that end platform, the GIS platform, to do the manual analysis? Or we don't capture data yet. I do want to leave plenty of time for Wesco to talk about how they've used some of these tools that Strayos has specifically within sites that they're managing. So let's go ahead and we'll close this one it looks like it's kind of a leading the combination of manual and AI, which I think makes sense. All right. So at this point, we'll go ahead and kick it over to the Wesco team. Go ahead, David, Curtis.
All right. Thank you, Kyle. Thank you, Ravi. Appreciate that. I was looking at all those things that Ravi was showing. I was like, wow, we're not doing all that. We should, you know, we need to do more of that stuff. So that's great. My name is David Moulton, and I'm happy to have Curtis Thompson here with me. We both work for Western Explosive Systems Company, or Wesco. Just a little bit about us. We are a Dyno Nobel joint venture providing blasting-related products and services to the mining industry in the Western United States, primarily the Intermountain West. And we're known for our excellent safety record and providing innovative explosive products and services. We service everything from quarry and construction sites to metal and coal mines, any type of mine out there. We service both surface and underground. And we're really known for our expertise in improving blast results to optimize downstream mining processes. You know, mining is increasingly technical, and there's always pressure on costs. And Curtis will talk a little bit more about that later on in our presentation. Okay, next slide. So we've been flying drones since about 2016. Right now we have a fleet of over 20 drones and spread over 5 states, 10 licensed pilots. We first started using drones to video our blast events. And when I talk about you know, blast events, just to give a little bit of context, you know, blast events, blast patterns, I'm talking about a series or a pattern of holes that get drilled in the ground. Typically, they're anywhere from 2 to 12 inches in diameter, get loaded with explosives, detonated, and that basically either takes big rocks and turns them into small rocks or moves material from one place to another. So just to give a little bit of context there. One of the things we found when we first started flying for blast videos was that changed the game for us. I mean, that gave us a whole new bird's eye perspective using these DJI drones to capture our blast videos. It quickly became the gold standard for video in our blasts. And the other thing we found is that that the drones were easy to fly, they were safe, they were quick. There were so many advantages to them that we quickly found ourselves looking for other opportunities to utilize drones in our operations. One of the things we found is, you know, the ability to build these 3D models, which was amazing. And, you know, they say that a picture is worth 1,000 words. Well, I think when we look at these 3D models built with drones, that they're worth 10,000 or 100,000 words. You know, you can show so much. There's so much information there. So we're just excited to talk about how we're using drones in drilling, blasting, and mining today. So next slide, Kat. So as I mentioned, we first started using the drones to capture blast videos, and then we found this ability to build these 3D models. And so then we were looking for other opportunities to use the drones, these models. And that's where we really found Strayos. Strayos had built these tools and capabilities for drilling, blasting, and mining. And so immediately, at least for myself, I started using it for profiling our blast faces, basically looking at kind of how much rock is in front of these holes along this rock face to help us optimize our blast designs. And that quickly morphed into being able to design entire blast patterns in Strayos, and being able to do mine planning in Strayos, and then being able to do post-blast predictions and analysis. I mean, things that we that at one point, you know, if it was possible, it was usually difficult to do those post-blast analyses. Now they became a reality, and even a kind of a regular occurrence. It just really transformed everything for us. And in addition, kind of as we alluded to earlier, now we're, you know, in the past where we were using survey and things were geo-referenced kind of as needed. Now we're finding everything that we're doing is geo-referenced, which is just a huge change for us.
Yeah, and the level of accuracies that something like an enterprise level DJI drone that has RTK module on it, whether it's the Phantom 4 RTK, sounds like you guys are still using, or the new Mavic 3 Enterprise, having that absolute accuracy, especially when it comes to drill planning, you're really going to need to be pretty spot on.
Yeah, and it's so easy with the DJI drones to be able to get them up in the air quick and flying, you know, just immediately, and have that survey quality data. It's just amazing. This is just a general workflow kind of showing our process, and I'm happy to, if there's questions about this later on, happy to talk a little bit more about it. But basically, we work with our customers to identify areas that need to be blasted. At that point, we'll put the drone up in the air, we'll do a fly to that area, upload those photos into Strayos, build a 3D model there, and then we'll do our design. And then we'll either go and lay that out, either actually mark it out on the ground with survey equipment, or we'll send it to the drills that are GPS enabled, and they can start drilling those holes. They'll drill those holes, and then once they're finished, we'll go back out, fly that area again. So now we have the actual as drilled hole locations. We can compare that with our design. We can look at our face profile, and we can really kind of finish up our blast planning so that then our blast crew can come in, they can load that blast pattern with explosives, perform the blast, at which point we put up another drone, again, to capture a video of that, and then we'll do another flight afterwards to capture the post-blast area so we can look at our post-blast performance. Just a lot of flying, and we may do multiple flights after the blast, just again to try to look and see how we've done, and just having a geo-reference and being able to kind of tie all that together it's been amazing.
Good
So
deal.
Go ahead, guys.
Yeah, I was just going to say, let's take a look at the Strayos platform, but I didn't want to interrupt you.
Nah, perfect. That's just what I was going to say. So I have a couple of demos here. I just wanted to show. The first is a demo showing doing a blast pattern design in Strayos. So we fly it with our DJI drones, and we upload the photos into Strayos. Strayos builds this 3D model for us of the area. In the process, the AI will identify what we call crest and toe lines. The crest are the orange lines, the toe are the yellow lines. Those just assist us in being able to design our blast pattern. And then we're able to pull in other reference points, like a polygon showing an adjacent blast, a back line that we can serve as a reference line so we can kind of line everything up. I've got a blast pattern that we've already built in here. And the process is really quick, easy, simple. I mean, again, you got that picture there. And then we can use an AI tool in there to optimize our face burden. Again, to try to make sure we're getting the best blast results, but we're also doing it safely. And so these tools have really just been ground changing for us.
So to jump in, Dave, just really quick on your face burden, and to clarify the importance and the safety side of this. So even before 3D profiling, most of the time the blaster would stand on the face and throw a tape measure down and try to guess where he thought the top of the explosive should be, so that we didn't have, releasing of face after the explosion goes on. So you can only see the safety input of somebody kind of hanging over the face or the berm of a high wall trying to guess. just the opportunity to throw a drone in the air and have the help from not only AI, but from our expertise to be able to utilize this tool is so immensely huge for not only the safety side of things, but for the efficiency side of things in the design process.
Yeah, that's a great point, Curtis. I appreciate you bringing that up. I mean, even this area that I'm showing here, you know, we also used to do 2D and 3D laser profiles, and I wouldn't even be able to use a 2D or 3D laser on this area, let alone, you know, when we're using those lasers, we'd have to have at least 2 people, and 1 person had to be standing down there dodging, you know, mining equipment.
Cool. And the next video.
So this one is showing a area after it's been drilled. Again, we've got this 3D model here in Strayos, and we've got we can load in our blast design into here, and then Strayos has what's called the hole caller AI tool that will go in and compare our design to our as drilled. Those different colors represent the level of deviation, which is really important for us actually knowing where the actual holes were drilled. And then the other part of it here is pulling in our Boretrack data, which a Boretrack is a device we run down the holes, measures inclination or angle, and then the bearing or azimuth of those holes. So we know kind of where they're going. Then we can look at how much rock is out in front of those in reality and say, okay, how much explosives are we going to load into here so that we can get the best results and do it safely.
That is really cool. Be very interesting to be on site and see one of those. Maybe I jumped a little bit too early. It'd be really interesting to go on site and see one of those ones that go down the bore holes. And then the magic happens, it looks like.
Yeah. We'll come out anytime, Kyle. You're welcome anytime. So this is the type of blast that we're trying to avoid. Maybe go back to that last one just real quick. Yeah, this is the type of thing we're trying to avoid. While it might look cool, you know, you're getting that part of the blast blowing out, shooting rock all over. Obviously, that's unsafe, but also it typically doesn't lead to the best blast results. Instead, we want the next video, we want more like this, where it's in control, we're containing the energy, we're getting the results that the customer desires. And that's the type of thing that we want, that our customer wants. And now we can start to look at our post-blast analytics. So at this point, I want to turn the time over to Curtis to talk about the post-blast analytics.
So real quick, going back to some of David's points on the drill hole accuracy, when you look at it in the standpoint of cost and efficiencies, a few inches to a few feet is a big difference in blasting. We try to be as precise as possible. You know, it affects your timing, it affects your drilling costs, it affects your explosives. Efficiency as far as breaking the rock, allowing us to break the toe so that we don't have those hard toes that Ravi was talking about where you have to bring in secondary equipment. So that point for Wesco in the ability to fly pre and post drilling has been a huge part for us to utilize the drones in reducing our costs as a drill and blast company. When you look at it in the standpoint of a lot of our contracts or a lot of our, you know, agreements are based off of either fragmentation or yardage, the amount of material that we blast every month. Having that ability has reduced the inefficiency of either overcharging or undercharging, or being able to monitor that efficiency so that we can go to our customers and they can feel 100% reliable on the data we're giving them through the reporting. So I just wanted to quickly, we kind of jumped over that really fast, but that AI of the drill holes is such a big part, especially in the engineering side, which me and David do for the most part, and that I'm going to kind of discuss now. It's such a big part in what we do every day, and the more that we do it and the more that our customers see the benefits and the cost, you know, the ROI of that, it just increases their trust. It increases our ability to help them improve, large or small, depending on what we're trying to do. So
just have
to
a
kind of move on.
Curtis, I think it would be really, I'm really curious, you know, to just kind of get a better understanding of, you talked about the collar deviation AI, drill hole AI, how it's benefiting. What was the current method before? How did you measure the pattern deviation before kind of drones and AI got into the mix?
Honestly, Ravi, we probably weren't, to tell you the truth. Our guys out on the pattern were drilling where they could, and then the blaster was making adjustments on the fly with timing and explosive load. But at the end of the day, once that hole's drilled and he makes the decision whether to load it or not, we're kind of stuck. You know, we don't have the data to say the fragmentation was poor or we had a hard toe or any of that. It was just a decision, the material was shot, and we kind of moved on.
Yep. I mean, the only other way to do it would be to go out and survey it, which, you know, that takes time and money to go out and do it.
Yeah, so almost like having a GPS and measuring each hole position, which is additional kind of a lot of hours, you know, to do that. Okay.
Perfect.
Yeah, so I mean, as far as moving on with if you can go back to that slide, Kyle, really quick.
Sure, yeah, sorry.
No, you're okay. A lot of what we do is measure, and measurability with accuracy and reliability is huge. And we talked about the RTK drones. That is something that Wesco has started utilizing probably in the last 2 years, wouldn't you say, Dave?
Yeah.
And it's really changing the game for us as a small blasting company, to be able to have that reliability and that accuracy so that we can't control what we're measuring. We can give them accurate data. As we started out, we weren't utilizing RTK, but we were able to still add value. But that RTK and it sounds like some of the new stuff coming down the pipeline is only going to continue to get better. But it's been a huge part for the safety, for the baselines, you know, the future KPIs that we put in place with our customers and be able to report has been a large part of what we're doing here.
Cool. Oh, I keep jumping forward too far. There we go.
No, you're okay. So as everybody knows, and as everybody, you know, tries to set a goal, mining is about cost. You know, we put safety first, but after that, we've got to be able to make money. We've got to be able to lower costs and improve operations. And we believe that utilizing drones and Strayos, this has been a fundamental part of us as a blasting company, kind of moving into that role with some of our smaller customers into that mine planning / analytical reporting. We believe that this is changing Wesco's future as how we as a blasting company can help mines lower costs and be able to optimize their operation.
I think the next one is a video here.
Yeah, so Dave kind of went through kind of the design / AI measured pre-blast, and what we are going to kind of move to is what happens after, right? Dave talked about, we film the videos, we watch it, kind of see, and then what? Are we moving forward in trying to capture the data to be better, to optimize and to move forward? And that's kind of where these tools from drones and Strayos has really helped us. So kind of some of the fragmentation workflow that we utilize with most of our customers is, you know, as the pre-flight, we go out and we fly after the blast. We're able to upload those photos and run an AI muck analysis, which allows us to create a fragmentation, not only 2D but 3D model, and allows us to put the graph on the right hand side to monitor basically the feed values. What is our optimal size? You're able to basically change or set up each site in their own fragmentation, whether they want 8-inch rock or 4-inch rock or as much fines as possible. We're able to help them monitor and optimize this through adjusting the drill and blast pattern. Without this AI, it would be very difficult. We would have to go, you know, 4 or 5 times out into the mine. We would have to shut down production, take our own photos with either a camera or a phone, which is time and money. Now we're able to, you know, park out of the way. We're able to fly this 1, 2, 3, 4, 5 times, however many times, and when we're done, we're able to have this graph and prove to our customers as a blasting company we're doing the necessary changes to optimize their program.
Good points. Yeah, downtime is money lost. Let's go ahead. Got one more blast video here. There we go. Let's try to pause it on a good one.
So here we're in this video, we're kind of showing the Muckpile movement. And as you fly for fragmentation, you can also run the Muckpile AI to be able to show you how the material was moved. This allows us to be able to optimize for the different equipment so that we can reduce costs and wear and tear. If you could go to the next slide, Kyle. So this shows the prediction of what the Muckpile is going to do based on our loading and our timing schemes that we put in there. This is a loader operation. This was able to help us improve with the loading processes and increase dig rates by moving the Muckpiles out so it's not so high. They didn't have to put secondary equipment on to assist in the loading. And then you can also see that is in the right hand, well, in the bottom part of the picture, you can see, you know, their crusher and their feed belt is right there. We were able to basically predict what we thought was a safe area for them to set up their crusher without being too far away. So this tool, being able to not only do a pre and post analysis of what the Muckpile is going to do along with the fragmentation, helps us show in the reporting to our customers and gives them credibility and accuracy of what we feel we can do as a blasting company. And it's really changed the game in a lot of the quarries and the mines that we're operating in.
That's great to hear.
So kind of the last slide for Wesco is, you know, we talked about where we were, kind of where we are, but where we want to go as a company. And you can see kind of the four things on top: people, process, technology, and culture. We feel as a company that as long as we innovate and integrate these things, we're able to build this workflow, build this community of progression and innovation and efficiency. You know, it's not about one person or one process, one place, one technology, but as we build this together, as we come together as a team and are able to operate as a team, you know, a big part of what we're doing with the AI and Strayos is if I'm working on a project, I can call Dave and I say, hey, will you jump on my project and look at the timing or look at the explosive load or, you know, maybe the burden in the face profiling, and get his expertise without having to send PDF reports. He can just do it live, real time with me. You know, that collaboration is huge. You talked about that cloud base with some of the new technologies coming through DJI, which we're looking forward to be able to utilize, and just building a culture of optimization, of safety, and long-term progression.
I love that slide. We've got a lot of slides on what we've done over the past 5 years. We see that quite often, but we don't see the moving forward slide. So love the focus there. I thank you both, David, Curtis, for being able to join from the West Coast side. Also, Ravi, thanks a bunch. We are going to go ahead and start wrapping this up. A couple key points. We still have that questions box. It seems like some of you guys got some good questions in there, so we're going to go through and answer those. The other thing that we want to highlight, maybe it's what some of you are waiting for, is that free 30-day trial of Strayos. Ravi, you want to tell us a little bit more about that?
Yeah, so we have a 30-day free trial of Strayos that we are exclusively offering for the attendees today. You just have to go to our website here. That's the first step. And then at the right corner, click on Get Started. And then just fill the sign up form. You will receive an account verification and approval email. And then you're all set. We have a bunch of tutorials and all the help guides, you know, for you to guide through. But if you have any questions, you can always reach out to our support team as well. That is embedded in the website as well.
Cool. That's great to hear. So all of the stuff that we've been seeing today, for those of you that are interested in this, we would love to see you test out that platform. And we hear that works really well with DJI drones. So yes, excited that you're able to offer that, Ravi. I also want to shout out the QR code on the right-hand side of the screen. That is for DJI, and that's for just reviewing, being able to answer any questions that we have for this DJI webinar. It'd mean a lot to us if you are able to review it so that we know what we should be focusing on. At this time, let's go ahead and dive into some questions. I am, just for fun, going to pull up, I think, my favorite part of the presentation, and we'll pause it right here. Cool. All right, so going through some of these questions here. Let's pause it on that AI side. Okay, going through some of the questions here. Are you recording this session? We are, so just sit tight. We will be able to get the recording out via our YouTube channel. Does the rock strata analysis pull in data from the drill rigs, or is that also based on drone photos? So good question for Ravi.
Yeah, so it does take the data from the drill rigs. If you have the sensor data, or if you have the aftermarket sensors that you're applying, you use that. We also have our own application, mobile app, where the drillers can log the drill log information, and we can combine that with the 3D model to build the rock strata.
Cool. Next question. Is there any way to take info into consideration the overburden for a particular blast pattern when using the Strayos or drone photos? The overburden for a particular blast pattern.
So this is something that Ravi helped us do for a small mining company. If you do have certain drill data of where your overburden and your ore zone, you can actually put that in and get data and 3D model put in there.
Cool. That's great to hear. This one's for the Westco team, David Curtis. What DJI drones is Westco most successful with? Not just what you have, but what have you been most successful with?
Well, we've been, I think we've had the Phantom 4 RTK. A lot of places are using that. That's probably what we've been the most successful with. Yeah.
Yeah, we're kind of moving into the Mavic 3 Enterprises. We carry a lot of equipment in our pickups, and smaller is better when you're trying to fit it all in.
Yes, it is. The form factor of it, a little bit longer flight time. There's definitely some benefits there, but we are still seeing a lot of Phantom 4 RTKs still going out there and putting in their 8 to 10 hours a day of work. So great to hear. Will you send the recording? Yes, we will. We would take a caller survey when we picked up the samples for ore control? Oh, would we take a caller survey when we picked up the samples for ore control?
I think the question is maybe could you? Yeah, you could definitely do that. You know, if they're not grabbing samples, they could easily put a drone up there and fly the area.
Yeah, I can jump in here. Yes, if you want to do a caller analysis, so that you can bring in and can analyze, where the caller deviations are. That's one of the areas where if you're doing a grade control project or ore control, the pattern deviation analysis is a huge help on the caller, especially.
Another question for you, Ravi, is rock heap prediction live on the Strayos platform?
Rock heap, or maybe I'm not understanding it right. Is that rock mass or rock heap?
Rock heap prediction.
May have maybe to get back on that later, because yeah, we don't have a rock heap analysis in the platform yet.
No worries. Let's see, we're getting a lot of them coming in. We will make sure to follow up with the questions and with answers after this webinar, since we're getting close to the top of the hour. Which model of RPAS unit are you guys using at Wesco, and are you using any additional products on the ground to improve accuracy?
Will you use that again, Kyle?
Yeah, which model of RPAS unit are you using? I assume the equipment that's going down the drill hole. Maybe I'm
like our Boretrack.
Bow tracking or probes. Is that probably what the question is?
Okay.
Yeah.
Sorry, go ahead.
I mean, we use a Carlson one, but we also use it. I think it's called Devico. There's a few different ones out there.
Sure. Have you guys dabbled at all? I've gotten two different questions in thermal and how that may be beneficial for mining, as well as LiDAR. Have you guys tried any of those? And Ravi, have you seen any benefits for thermal?
Yeah, I'll jump in and let David and Curtis chime in. Yes, so LiDAR has a huge benefits, especially on the mining use cases. Personally on the rock mass analysis, you can get a lot more detail for each smaller joints and cracks. So that's one area. And of course, the environmental survey, if you're doing a lot of tailings survey, and if you want to get more precise on the movement analysis, that's another big area. Then the thermal side, especially I see the blasting is one of the major use cases that can be applied for. The data is a bit difficult to work with to understand kind of where the gas ejections are, blast fumes. So huge use case, but then also the if you're a gold mine, if you're doing a lot more slope movement analysis, so you can identify based on the temperature conditions where the hot spots and cold spots are to understand where the possible movements will occur. So really good use of the thermal data is there. And we're kind of working towards to apply and bring those thermal data in these use cases as well.
Cool. Well, we are 1 minute past the top of the hour, and we want to be cognizant of people's time. So thanks everyone for joining this DJI webinar. I want to give a big shout out to the Wesco team and to the Strayos team for being able to help put this together. This is being recorded. It will be posted, and we will be following up. And hopefully we see some of you guys take use of that 30-day free trial. So thanks again, everyone, and see you on the next webinar.
Thank you again, Kyle, and thanks everybody for joining in.
Sure
Thanks,
thing.
David, Curtis. Yeah. Bye, everybody.